Hi, welcome to part 3 of the video series about physical quantities. In the previous one, we have learned how to represent a vector. Then, we have discussed equality of vectors and negative of a vector. Finally, we have seen how to multiply a vector by a scalar. In this video, we will learn adding two vectors which are either in the same direction or opposite to each other. And then we are going to see how to add vectors which are not parallel. Let's start with the simplest case, adding vectors in the same direction. It will be easier to explain it by using an example. Calculate the resultant force applied on the object in the figure. There are two forces applied on this object. The first one is 6 newtons and the second one is 9 newtons. And both are to the right, meaning they are in the same direction. We can start to solve the question by defining resultant force or resultant vector. The resultant vector is the single vector whose effect is the same as the individual vectors acting together. For this specific question, we need to find out a single vector which will have same effect as the two vectors in the figure. To calculate it, we draw the first vector and from its end we draw the second one. The resultant vector will have the same length and direction as both vectors together. We can replace two vectors with a single vector pointing to the right with magnitude of 15 newtons. The second case is adding two vectors opposite to each other. The question is, calculate the resultant force applied on the object in the figure. Again, we have two forces of magnitudes of 6 and 9 newtons. But now, one of them is to the left and the other one is to the right. We can take the first vector and add the second vector on it. It's easy to see from the diagram that the resultant vector will be 3 newtons to the right. Even though the solution is correct, it is not a method we use in an exam or test. The required method is same as for addition of vectors in the same direction. First, we draw one of the vectors, then from its end or head, we are drawing the second one. The resultant is the vector combining the tail of the first one with the head of the last one. It is 3 newtons to the right. Now we are going to learn two methods to add vectors which are not in the same or opposite direction. In other words, which are not parallel. The name of the first one is tail-to-tail method. The name of the method gives us hint about the steps we must take. First, we draw two vectors by bringing their tails together. Then, from the heads of each vector, we draw parallel to the other one. As a result, we are getting a parallelogram shape. The resultant vector will be a diagonal combining the tails of two vectors and the connection point of two parallel lines. Let's try to use same method again on two vectors in this figure. If we follow the same steps, first we draw the vectors by joining their tails to each other. Then we complete the parallelogram by drawing lines parallel to both vectors. Finally, the resultant vector is the diagonal of this parallelogram. Another method of adding two vectors which are not parallel is tail-to-head method, or in some textbooks you can see it as head-to-tail method. In this method, we start addition by drawing one of these vectors. Then, as mentioned in the name of the method, we draw the next vector by joining its tail with the head of the previous one. Resultant vector is drawn starting from the tail of the first one and ending at the head of the last one. Unlike tail-to-tail method, we can add more than two vectors by using tail-to-head method. In this example, we will try to add three vectors shown in the figure. It's not important in which order we are adding vectors. We know from the maths that, for example, 3 plus 5 is equal to 5 plus 3, or 1 plus 2 plus 3 is equal to 3 plus 1 plus 2. Same is applicable for the addition of the vectors. For this specific example, we can start to solve the question by drawing the vector on the right. Then, starting from its head, we draw the second vector. Afterwards, we draw the last vector from the head of the second one. To summarize, we draw each vector from the head of the previous one. The resultant is the vector drawn from the tail of the first one to the head of the last one. On the last part of this video, we will learn how to add two vectors which are perpendicular to each other. The question is, calculate the magnitude of the resultant of the two vectors in the figure if the magnitude of vector A is 5 and magnitude of vector B is 12 meters. To solve the question, we can use either of the methods we have learned before. In tail-to-head method, first we draw the vector A, and from its head we are drawing the vector B. The resultant vector is the vector starting at tail of A and ending at head of B. In tail-to-tail method, we draw both vectors by combining their tails. Then we draw parallels to each of them. And finally, the resultant will be a diagonal starting from the tails of two vectors. In both cases, we have a right triangle with A and B as its sides and resultant as its hypotenuse. According to Pythagoras' theorem, square of a hypotenuse of a right triangle is equal to the sum of squares of two sides. In other words, C square is equal to A square plus B square. We can apply this theorem in our question to calculate the resultant vector. Square of the resultant vector is equal to A square plus B square. After substituting A and B, R square is equal to 5 square plus 12 square. If R square is equal to 169, R is equal to 13 meters. For this question, we were asked to calculate only the magnitude of the resultant vector. In our next video, we will learn how to calculate the direction as well. To summarize, in this video, first we have learned how to add two vectors in the same direction, and then how to add two vectors which are opposite to each other. Afterwards, we learned how to use tail-to-tail or tail-to-head method. Finally, we have added two perpendicular vectors. This video concludes the topic of physical quantities for grade 10. In the next video, we will dive into grade 11 topic and learn about components of a vector. Thanks for watching. Don't forget to subscribe and turn on the notifications in order to be updated about my new videos.